So amazing to be here, and thanks for tuning into my session. I hope you get something out of this. And like Andy was saying, I will be around after this session to continue the conversation. So hello, my name is Developer Steve. I'll get to that in a little moment. I do come from the future of time zone of GMT plus 11, and I bring with me, for those not in GMT plus 11, the gift of the metric system. I'm joking, you don't have to accept it, but please do. Anyway, I hope you find this session fun, and it is really cool to be here. Please drop any or all comments, questions, and emojis into the chat, or feel free to reach out and connect on socials beyond this. I always love geeking out and, well, just connecting to people, because it's always fun. Anyway, before we do get too far underway, I do have a bit of a disclaimer. It's even got an asterisk. That's how important it is. But anyway, I do have a disclaimer. I do like tech jokes, and I always love opening my talks with one because, well, much of the stuff I'll be demoing today, and I have two demos which are totally going to work. Yes, Murphy's Law can go away because they're totally going to work. But this is an open source joke, so please feel free to share with anyone, or like with any good open source project, modify it and still share it around. Always wins. But anyway, oops, I've just broken my thing. There we go. How do fallen trees check for errors? Oh, you'll be like, why would trees be checking for errors? Well, if they, oops. Oh, that was the punchline. This one doesn't have the thing on. Anyway, no use slides animations. Anyway, how do fallen trees check for errors? They use log files. See, I have a sound effect. I have a whole bunch of fancy video and audio things, and I have a booms, but I'm just going to make the noise. So anyway, like I said at the start, my name is Developer Steve. I'm one of the senior developer advocates at Lumigo. Recently, also AWS community builder, which is really cool because, well, I love connecting to coding communities, to DevOps communities. Well, just love geeking out with tech folks. I've been in tech industry a very long time. Been coding since the age of 8, but I'm going to talk about that in a small minute. In the time before the events of the last few years, which we won't mention, but in the time before, I did a lot of traveling and a lot of conference talks. So I did my 100th conference talk in 2016, and then stopped counting because I figured once you hit 100, anyway, I stopped counting. But through that activity, I was literally able to connect to some amazing communities, a whole bunch of Python conferences around the world. But then everything kind of changed, and well, I moved away from the city and now live in country New South Wales in Australia. So I live in a rural part of Australia. We also now organically grow my own food, which is really cool. And I've never lived out in the country before. It's been kind of fun. But I also own horses too, and that's Captain Dan, by the way, and Astro Boy. They're ex-race horses that me and my wife rescued, which is kind of fun. And I'm going to introduce you to a new star of the show recently. This is Lambda the Lamb. Little Lambda. Now, it's important to note here that in the country, the rule is if it has a name, it is not food. And so the vegetables do not have names, and Lambda the Lamb does have a name. So just want to point that out. Anyway, that's not what we're here to talk about today. And like I said at the start, or like I said in that last slide, in my intro, I've been building apps for many, many years now. Back in the day, and going back a ways here, a bunch of moons ago, I taught myself I learned BASIC on an Atari 800 XL, which is my first computer. Actually, I always love asking this. So in the chat, drop in, or even after this, come to the face-to-face session and let me know what your first computer was. Yes, it was. I always love geeking out about that because it's always interesting to see where everyone started and where you are now, the developer origin story, if you will. And then even working through my developer origin story, working with through digital agencies. And I love digital agencies because, well, as a DevOps, it really put my skills to the test of being able to meet those sometimes tricky client requests and, well, delivering everything. And it was literally organized chaos, but it was great to be able to put my developer skills to the test, particularly using my Python skills to build out a whole manner of different things. And then, of course, more recently, building out cloud native specific applications across multiple microservices, across multiple clouds, has always been, well, the next level of that whole developer challenge, sort of taking my ops and my dev and mixing it together into that thing we call DevOps, and then deploying that across, well, like I said, across microservice cloud and a multiple of clouds. Always fun, particularly when you're building for scale, which you should always be doing from day one of any project. And Python for me, even across my developer origin story, has always been great because it is that very versatile language. That's why we're at this conference today. And well, why we use it all the time, because it is literally one of my go-to tools for versatility in my DevOps, in my dev, in my tech and my geek toolkit. And I've used it, actually, when I first started using Python, it was, I think, back in the early 2000s. I was using it for game dev, using Tickle and building out. It was actually a friend of mine was building an RPG or MMPORG. I always get the letters wrong. And it's 1 a.m. It's 1 a.m. Anyway, yeah, I was building out a game dev client, which is where I started to learn Python initially, which was great because it started to, that was a great way to learn, not only start to learn Python, but learn the versatility behind it. And of course, building out APIs, and I do love a really good API. Actually, that's a talk for another day, but yeah, anyway, I won't get into that now because I will run out of time. APIs are really cool, and Python in particular is that heavy lifting, versatile language to be able to build out some really scalable APIs. Of course, data science, it's been used for a very long time. In particular, one of the ones I have used, or one of the libraries, frameworks that I've used extensively over the years is, of course, Torch, which that's still kind of a favorite. Of course, web, and actually the two demos I'm going to be playing with today is I'm using Flask because I really like Flask like a lot. It's one of my favorites. Well, actually, it is. I'm going to say it's actually it is one of my favorites. It's just so light and easy to use, and the routing it's pretty cool. But anyway, I've got code and demos, two demos that will actually totally work. And of course, Internet of Things. Now, I am going to mention here this, and for those in the Slack, I did post a picture of me and my Wookiee friend Salkaza, not Chewy, Salkaza, licensing reasons. Anyway. These fun board we got in the swag pack was it turned up the other day, and it's actually pretty cool. And I've been doing some fun things with Python. Anyway, if you are doing, I love IoT. If you are doing some fun things with this board, please come to the face-to-face after and tell me about it, because there's some ideas that I've got with it. Anyway, and I need to hook it up to Home Assistant, which it totally does do. Total tangent. But one of the other projects I've used MicroPython before is I got this coffee table that looks like an iPad one time, and I thought, wouldn't this coffee table be fun with 300 LEDs in it and like an ESP32 talking to my home server, and perhaps I could also use it to change the color of said coffee table. Anyway, whole other discussion topic right there, but this was a whole bunch of geeky fun. Again, come to the face-to-face after, because we need to talk if you're doing fun things with that board. Anyway. But one thing I've always noticed through my developer origin story is beyond that initial deployment of that application or that project you're building out, like unless I'm constantly observing that particular application once it's been deployed, I don't know what it's actually doing. And this sort of comes down to another principle, principle from the quantum universe. Quantum universe? Yeah, from the quantum world, around a concept called Schrödinger's cat. And for those that don't know, this is essentially the same type of thing where essentially this is a thought experiment where you put a cat in a box and close the box. And without observing that particular cat, you don't know what state it's in, whether it's materialized, dematerialized, whether it's even in the box at all. And it's the same thing with app development when you think about it, or app deployment, because beyond that deployment state, unless you're observing the logs, and sometimes those apps create a lot of logs. And if you think about microservices, there's a lot of logs being generated across a multiple of services, sometimes across a multiple of clouds. And my head's already exploding from the quantum thought experiment, let alone the fact that I have to go across a multiple of different things to be able to find a needle in a haystack in a log somewhere in a galaxy far, far away. We've all been there before. Even when you know that there's a particular error appearing in your application, trying to find that one log somewhere, whether you're observing or not observing or observing your application, is sometimes quite tricky. Of course, in Python, the base language framework, and even in a multiple of the frameworks that I've talked about earlier, like with Flask and with Django, for example, there's a multiple of different ways or a multiple of different methods, techniques to be able to identify issues or to trace and debug an application locally. So using some of the core debugging functionality, like print, for example, or logging warning, or even PDB, say that fast 3 times, PDB, are just some of the ways that you can output into your local environment to be able to see what your application's doing and where errors are being thrown, etc. And then there's libraries as well, with PP print, which I'm always a big fan of because it's so much easier to use, and particularly when you're dumping out arrays and stuff. Anyway, and then IDEs, of course, have their own built-in tool suite, like VS Code, for example, and Eclipse have a whole bunch of really cool tools to be able to debug and essentially trace your application locally and see what things are doing under the hood. But as devs, as DevOps, as technical folk, there's always new ways that you're looking to trace a deployed application. And so that's where Schrödinger's app came from, because I created this to be able to see like what type of, or basically create errors or create routes on infrastructure to be able to see exactly what is going on in the platform or what is going on with a particular error type that appears, and then being able to see how you can identify that in a deployed application. This can be run locally or also on deployed infrastructure, which is the 2 demos we're going to be looking at today. Now, you might have noticed there's another tech joke on there. Now, this is a fairly old one, so if you already know it, well, you probably have it in the chat already, but what do you call 8 bits in Python? A snake bite. Oh, I didn't say these tech jokes were good. I actually have a whole bunch of these, so yeah, if you come to the face-to-face and you want to hear some more, then yeah, I can tell you some more. So this is as you probably gathered, this is a to-do app, and there's a few things or few base routes sort of built into this, and a couple of fun ones as well. Actually, I'm going to tell you my favorite HTTP status. Probably didn't think anyone could have a favorite HTTP status, but I do. We'll get to that. It's actually, no spoilers. Anyway, there's a few routes built into this application. So it's using Flask, which, well, I've already said that I'm quite fond of. It's using Alchemy to do its databasing because it's just a to-do app and I didn't need a fairly extensive databasing solution for it. So Alchemy is rather easy to use. So the 4 base routes that I've already built in, there's a get, so we can get a list of the current to-dos. There's a post, so we can create a to-do. We can update a new to-do item entry, so mark it as complete or finished. And then, of course, to delete as well, because once they're finished, I don't really want to see it again as a user. Anyway, let's try the first demo. So this is my code. Now, this application too is on my GitHub, and I'll put up the link at the end if you want to try it yourself. Or actually, I do need to do a pull request to this because I was testing it earlier and realized there was a couple of libraries I needed to update when my Mac updated. But anyway, that's a whole other thing. So I do need to push an update to it. But if you wanted to give it a try and there was something you found in there that you wanted to fix or you think could be done better, then please always open the pull request. Anyway, like I said, so I'm using environmental variables in a deployed version, which we'll look at in a little bit, because friends don't let friends ever hard code variables, particularly credentials. That's probably a talk for another day, probably a security talk. But anyway, please don't hard code credentials because it'll just save you. It'll be painful later on. Your future self will thank you in advance. Then, of course, the actual Flask routing. I've got the post route to add a task because I'm going to post it to itself and then process. I could also run an async route and then sort of pick it up and do a fancy no refresh. But I was being lazy and doing a redirect because Flask actually does really good redirects. Anyway, delete task and update task, and then there's some other ones in there too, but we'll get to those. So let's go to the demo. Now I'm running this one locally for now, but I'll get into the next demo we'll do is this, but a containerized version. There's a couple little things I've added to that as well. So this is the app here running. Yes, and I've just refreshed it. And look, I can actually see the get route coming in. Amazing. So it's working. Do a test one. You can see there I'm getting like a post. It does a redirect, but it's initially throwing a 200 because there's a post request coming in to create a new entry item, which you can see there. And of course, I can mark that as finished, and it's just going to do an update on the particular route, just using the Flask routes as we were looking at before. And of course, I can delete that as well. So one of the things I've built in here, there's a couple of these, is I can also enter cat as a task item, and it gives me this wonderful little cat button. So, and this is where I can start simulating 400 errors, for example, by just continually hitting cat, and it's going to cycle through, it gets stuck on a redirect because it's actually throwing a, let's just off screen there, it's actually throwing a 400, and then I have to manually click through because it's a Flask thing. So, but this takes me back, and you can back to the main screen, and you can see there's one cat there. So if I click it again, it's going to throw a 401. So what I can do is just keep clicking that, and it's going to continually throw me 400x or 4x errors, constantly just cycling through them. So 401, 402, 403, which is handy in a deployment method or deployment scenario because I can then simulate some 400s or simulate some 500s or whatever I need to simulate to make sure that my app's able to pick up and handle those errors being thrown. I can also, using another one, HTTP stat, I can also trigger specific HTTP errors. So can you guess what my favorite HTTP status is? It's 418. You might be thinking, of course, why would it not be anything else? So for those that don't know what 418 is, ooh, did I break it? Oh, I didn't. 418 is I'm a teapot. This was added a number of years ago as a bit of a April Fool's Day joke. It actually made it to the HTTP status list, and it's never left. And I'm kind of glad. Completely useless, other than it's a teapot and it's fun. This is one of my favorites to always test apps on, just to see how they handle and make sure that they're not only picking it up, but also appearing in the logging, so I can see what it's doing. That ends the first demo. And hopefully the next one works as well, because that's a little bit more trickier. But anyway, that is the first demo. And as you can see, you're able to like output different status types using the app. And well, we can actually see it really, really easily. But that's only part of the journey, because it gets a little trickier when you start to look at deploying this across a cloud, particularly when you're dealing with like multiple, for in the microservice world, because you've got all these different little services behind your application that your application sits across, sometimes across multiple regions as well. And of course, we all know the old, I've used this before too, because it did work on my machine, ops people. It doesn't work on yours. Of course, with containers, that kind of eliminates it a little bit, but not completely. So like I was saying, in the cloud native world, you've basically got all these tiny little microservices that your one application now can sit across as well. So gone are the days of either having that one monolith or that one big server or the array of servers, etc. Like now, a lot of these applications, or a lot of the more modern cloud native applications, are built across a multitude of services. And of course, when that proverbial demo that doesn't work, no, it's totally going to work. When that proverbial error happens, likely on a Friday night or a Saturday morning at around 2 a.m., probably after my talk, because it almost is 2 a.m. No, it's got like another 30 minutes or something. When that one error appears in that one service sitting in that one region in a galaxy far, far away, and you're wiping the sleep out of your eyes to try and determine where it is, well, we curse Murphy's Law and pick through a multitude of logs to be able to find out where that actually is happening. And this is known as distributed tracing, where we're able to pick up and trace a particular invocation or a particular path through a multitude of services to pick out that one transaction and essentially make sense of it all and put it into order. So what distributed tracing does, for those that aren't familiar with it, is you're able to map your one transaction or a particular transaction, its journey or its quest, if you will, through those multitude of services across the multitude of regions to, well, essentially save you picking through all the logging. Because, well, I've been there and friends don't let friends do that. So when that proverbial incident happens in that one microservice in that galaxy far, far away, you're able to determine where it actually happened inside that particular trace, which is really handy because sometimes where you think it's actually happened isn't actually where it's happened at all. It's 3 steps prior in another, maybe in another completely different flow where that one variable isn't being set and you aren't able to see it because, well, you can't see the full picture of where that data came from and where that trace line is. And what I really love the most about this, and this is using something called Open Telemetry that I'm going to talk about in a minute, is this is agentless now. So you don't even need anything running or any particular service running to be able to do distributed tracing across a multitude of services inside your application. You might be thinking, what, agentless? I've dealt with those agent things before, and well, they can be a little hair pulling, making sure that they're running and then making sure the logs are being sent in the right place and that no firewalls are blocking them, et cetera, et cetera, et cetera. So what this does is use an industry standard protocol known as Open Telemetry, which is part of the CNCF. It's been around since 2019. It is vendor neutral, which is amazing because friends don't let friends get vendor locked into anything. Like, why would you want that? What this does is create an industry standard way to be able to trace that data through a multitude of logs across a multitude of regions to be able to, well, essentially simplify your logging output into a nice traceable picture of where that error happened or where that data flow was able to come in and do the things that it was able to do. So one of the things I love the most is there's a multiple of languages supported by the open source community behind this, or there's a multitude of open source communities that are working with this project to make sure that every language is covered and every language is able to support that vendor neutral way to be able to essentially trace these invocations or trace these things through those microservices really, really easily. Which is really cool because as a fan of open source myself, and actually I am going to mention here, if you are looking to use any of these different languages to trace your app, please contribute back where you can, because it's always important, much like my joke, always important that you contribute back and, well, help make the ecosystem better, because like with all good open source projects, the more contributions and the more people that get behind it, the more better it is. The more better, it's 1 a.m. More better will work. But yeah, and if you are already contributing, then thank you for helping build out the ecosystem and saving people from picking through logs, because, well, no one wants that. I know I don't, and I've done it before, and yeah, it's not fun. Anyway, this is really easy to set up, and we've actually got our own open source version. So we've been able to fork some of the languages, in particular the Python one that we're going to be looking at in a sec, and be able to, they're really easy to set up and get up and running inside containers. Essentially, you install the tracer. You know what? We're going to look at it in the code in a sec, but reference it in the code. You configure 2 variables, which I'm going to show you the variable names. Well, actually, there they are there. OTEL _ service _ name, and then you set Lumigo _ tracer token, just so we know, well, whose app we're talking to. So I've got a containerized version of the app we just looked at with a couple little tweaks done to it. So essentially it's it's the same Flask app, Dockerized or containerized. I think containerized is probably the more apt term. And then deployed into AWS's ECS. And I've also added in a little SQS. So there's a simple queue service connected as well. And then I'm using, like we were just talking about, using Open Telemetry to do some tracing inside Lumigo. So demo number 2. So if I switch back up to here, you can see I'm using I've got that Lumigo Python library, and that's also available. Well, I just pip installed that. And then actually that's all I needed to do. I don't know why I seem surprised. This is my demo. Anyway, so I'm calling the library, and then what I'm actually doing, so here's the containerized version. Let me make that a bit bigger. You can see here, I've also inspected element, hidden the key, a variety of keys, because last time I did this talk, I made the mistake of not doing that. And well, anyway, someone was watching and like I was getting some extra messages through. Not today. No, not today. You can see here, I've got the AWS access key and secret set up as environmental variables, which I was referencing inside my code. That's just for the SQS integration. And then here's these other open telemetry tracer library things that I was talking about as well. I'm also setting a tag here because I can use that inside my app inside my traces to identify a particular app that I might be interested in over other apps. There's some fun things I can do with that as well. This is a deployed, like I was saying, this is a deployed container onto ECS. Pretty straightforward on that side of things. And then this is the app. So let me make that a bit bigger. There we go. And let me refresh that. And it's still running. Hey, we're good. So like before, I can do the same thing as I was doing before. I can create a new to-do item entry. I can finish that, which is now marked complete. And that, of course, did the update trigger as well. So we'll be able to see that in a second. I can delete that as well, which will cause the delete thing to happen. And I can then trigger using my cat powers. There we go. I can start to trigger those 400 errors just like before. Hopefully, there's one of these that I trigger and it kind of breaks the front. This might be that one. Oh no, it's not. Ooh, thought that was going to be the one. There we go there. And I can do the HTTP stat 418 teapot, which actually used to show up in the Lumigo. Look at that. See, there we go. Oh, hi. Whoever did that, come to the face today. Well played. Well played. Anyway, the other one I can do, however, and this is I can do meow. There we go. So what this is doing is it's putting into the SQS queue, the SQS, it's putting into queue meow, and then it's going to iterate through the meows. Still love that someone's put hi. Anyway, and then it's going to iterate through 3 meows, 4 meows, etc., etc. Now, why is this important? Because similar to before in that first demo, where we were doing the output into, well, we can see the output from all this happening. We can do a similar thing inside Lumigo dashboard using that tracer library, using that auto tracer to be able to see things that are happening because we're able to auto trace that particular cluster that's running. So you can see there, this is the Schrödinger app cluster that we were just playing around with. And I can actually see the transactions that are coming through and then be able to trace particular ones. So there's the 401 that I was throwing with the cat errors, and you're able to then see all the log entries associated with that. There we go there. So I can see where that's come from, and then all the information about, oh, that wasn't supposed to be there. Oops, now I'm gonna have to change that. Anyway, there was a token there. Anyway, what we can also see as well is, this should be the one, there we go. So it's generating the actual app being called, and then also the queue that then initiates the meow queue. Meow queue, there we go. So you can see there meow 3's in there, and if I go through, I'll be able to find there's meow 2, or meow 1, meow 2, and meow 3. And then 418 should also be throwing in there as well. But essentially, anytime I call that particular route now, or any particular error types appear, because of that distributed tracing through the application from that library, automatically, where's my 418? 418 should appear in here as well. It actually used to show I'm a teapot. Let me finish that and see if I can get that to start it. It should be throwing that. Start 418. I know what's going to happen is I'm going to come back after this to clean up this, and it will appear, because why wouldn't it? Murphy's Law, it always strikes at 1 a.m. It does show, but it's not showing at the moment. Maybe if I try refreshing. This is another way to debug. You just refresh the screen sometimes. It is in there. Anyway, here's one I prepared earlier. Now it's probably going to appear. I think it might be, this could be why, because I was on page 1. 412. See, it used to show 418. There we go. It used to show, I'm a teapot against that, but I don't know if it's, no, it used to. I thought it did show it on one of these pages. Anyway, I know that's going to appear once we actually finish this. But you can see, like, being able to trace through that application is really handy once you deploy, particularly when you go across those those multiple of services across with your app, particularly if you're dealing with data going into queues and stuff, you're able to see, there we go. This is one of my IoT demos. You can see it's coming in through Gateway, triggers a MQTT Lambda script, or just the Lambda script that I've called unassociated with a Lambda to Lamb, of course, and then stores in a DynamoDB, but it's able to trace all that through the one application. Anyway, switch back to the thing. There we go. Remember, if you have any questions, comments, or emojis, please drop them into chat, and come and see me at the end of this. Just got a few more slides to go through, and then looking forward to geeking out with everyone in the face-to-face session. So, just some takeaways. Remember to always build for scale. That initial, building out of the application, even just an idea, always be thinking, how am I going to take this to 100,000 people, or 100,000 users down the track? Build for 10 users now as a prototype with the idea of building out your application further down the track. Always important, because your future self will be kicking your past self if you do not. And we've all been there. We've all been there. Remember to rinse, repeat, and refine anything you do. Always super important, whether you're building out code or even just, throwing 418s, because 418s are a little teapot of fun. Remember to always keep leveling up that one thing works well, or could have worked better. Maybe we'll do it this way, etc., etc. Rinse, repeat, refine. Always super, super important. Of course, always remember to monitor and trace everything, because friends don't let friends. Don't do that, because you don't know what's running inside your application and what it's sometimes doing. Your users could be pulling their hair out because there's that one thing appearing in a log somewhere in that galaxy far, far away. I'm not quite sure what it's doing, but it mustn't be doing anything if no one's complaining about it. So anyway, point is, make sure you're tracing and monitoring everything, because those logs are building up and you want to make sure you capture anything that could be going wrong. This is the link, which I'll put into the Slack as well, if you want to go and take it for a spin yourself. I will have to do a push to that, because there's something I need to fix there. But anyway, there's the code if you want to go take a look. And remember, just finally, remember to always use your tech superpowers for good and be excellent to each other. Thank you very much.